Today we are going to discuss the data warehouse architecture. The data warehouse today's architecture is not the actual architecture that was in preliminary state. It has evolved a lot. Initially, data warehouse was just collections of different database, like the client server architecture. In this architecture, there were a number of different data servers which were connected to a central data server, and this data server was used to access the different server and worked as an common interface to access all the data available on different servers. There was no special processing tools or anything like that. It's just simply retrieve data through different server which are connected to the central server, and it's use the simple RDBMS queries, and this data just done one thing, that it reduced the duplicate data which were called as redundancy. In this data warehouse, the problem was that with increasing number of users and increasing complexity, the efficiency decreased a lot. And in this way, it needed a necessary improvement. And so the single tier architecture, that was the like client server model, in which there was centralized system, in which there was a central server, was not very efficient to handle large number of user, and was not also scalable for handling huge number of server. To resolve the problem, then came the two-tier architecture. In this two-tier architecture, the physical data sources were separate from the central server, but here uh, here the integration process was much refined, and they used to integrate and aggregate or generalize the different data collected through different server, and so it has solved the problem of redundancy. But since it was just using the SQL queries, and we know that the SQL queries become so time taking after when the complexity of the queries increases, or when the number of users increases, like the join operations of one or two table is may run efficiently, but if the join process uh, continues for 9 to 10 number of tables, then its efficiency reduces drastically. So, due to the limitation of simple SQL queries processing, this architecture that was solely dependent on RDBMS database and SQL queries was not efficient to handle large number of user, and was also not expandable to join different number of uh, yeah different numbers of data tables or databases. To finally reduce the increasing demand, to finally eliminate these problem, and to provide better service for increasing number of customers, then came the three-tier architecture. In three-tier architecture, basically there are three tiers: bottom tier, middle tier, and top tier. It is basically based on the concept of parallel programming, in which we use the relational database, but in slight different way with involvement of the OLAP tools. In the bottom layer of this architecture, the database of the data warehouse were the traditional RDBMS system, and but here it performed the ETL process, the cleansing, transformations, and loading the data, and using the backend tools. So at the bottom level, still there were relational databases, and but they were cleansed, transformed, and loaded before doing any transactions. In the second layer, there was a main change. In the middle layer, there and then here there was OLAP servers. These OLAP servers are certain relational OLAP and MOLAPs which were used. These uh, these two servers actually did the thing that they divided the multiple queries on or multiple queries to different processor like the shared nothing, yeah, shared memory architecture through the shared memory, and they work parallelly, and they, after processing the query, different segment, they provide the final aggregate results, yeah, summarized results. And in this way, the OLAP tool were able to handle multidimensional queries and handle the different dimensional independently. And after that, they used to merge all uh, these processing as a final outcome. In the top layer, there were the certain APIs, application layer interface, which hide these parallel processing and give the users a feel that there is a single system which is executing their query and providing their results. So at the API level, users were able to manage their data with the help of data abstractions. It also provided some query tools like reporting tools, query tool, analysis tools, and data mining tools. The architecture, the architecture of the dataware three-tier architecture is shown in this diagram. Here I'm increasing the size of the diagram. After zooming, this is the architecture of the three-tier data warehouse. Here at the bottom level, there is operational database system base, which are after cleaning and transformation and transformation and removing the redundancies and noise. The Through the ETL process, they are integrated into the data warehouse, where they are managed by different data marts for particular fields. And above all these, there are the third tier, which holds the APIs and the other tools, reporting, analysis, and mining tools uh, available, which provide the abstraction of the database to the users and the supporting tools. To As I told you that the OLAP server were able to handle the multi-dimensional database and to provide provide them facility to work efficiently. The database need modifications. In this modification, the new type kind of schemas were designed to handle multidimensional data, like data cubes, index data, and data cube index data, and new schemas like snowflake schema, fact constellations, and the index series. In relational database, we were not efficient to handle multidimensional data. These multidimensional database compress the size of the large volume of data to a very smaller size. In this way, it was easy to store data, and it was